All right, let's do this. The exam is breathing down your neck, and you have got to nail the path of blood flow through the heart. Don't worry, we're going to make this quick, easy, and actually kind of hard to forget.
I can picture it now. You're surrounded by textbooks, highlighters, maybe a little too much caffeine, and you're trying to track this one tiny blood cell on its epic journey. Yeah, we've all been there.
So let's just cut right through all the noise. For the next few minutes, you and I are going to follow that blood cell from your big toe all the way to your lungs and back out again. I promise, by the time we're done here, you're going to have this whole path locked in.
Okay, before we trace a single blood cell, you got to grasp this one big idea. Seriously, if you get this, everything else just clicks into place. Your heart isn't just one pump. It's two pumps, sitting side by side, each powering its own loop, its own circuit.
Okay, so check this out. This is our roadmap. See the two loops? The one up top? That's the pulmonary circuit. That's the right side of the heart pushing that blue, oxygen-poor blood just a short hop over to the lungs. The big loop on the bottom? That's the systemic circuit. That's the powerful left side of the heart pumping fresh, red, oxygenated blood to literally every other cell in your body.
All right, let's break this down. This is super important, so stay with me. The pulmonary circuit, its destination is the lungs. It's powered by the right side of the heart, and it's a super low-pressure system. It doesn't have to pump very far, right? Now the systemic circuit, its destination is the entire body. It's powered by the powerhouse left side, and it's a high-pressure system. That pressure difference is everything. Keep that in your head as we start our journey.
Okay, time to start the trip. Let's imagine we are a single deoxygenated blood cell. We've just dropped off our oxygen delivery to a muscle cell, and now we've got a new mission. Get back to the lungs and get a refill fast. So, how do we get back to headquarters? We jump on one of two massive superhighways of the vein world, the superior vena cava, which brings in all the blood from your head and arms, and the inferior vena cava, which collects all of it from your legs and torso.
And boom, both of those big veins dump us right into the right atrium. Think of this place like a lobby or a waiting room. The walls are pretty thin because, it's not doing any heavy lifting. It's just holding on to the blood before it moves on to the next stage. Now, to get from this lobby into the main event, we have to go through a one-way door, the tricuspid valve. It's called that because it has three little flaps, three cusps. Its only job is to swing open to let us through, and then slam shut so we can't go backward. And just like that, we tumble down into the right ventricle. Now, this is the first real pump of our journey. As soon as it fills up with blood, it gets ready to give us our first major shove.
With a big squeeze, the right ventricle contracts and forces us through a second door, the pulmonary valve, and shoots us into the pulmonary artery. And here's a classic exam question, so listen up. This pulmonary artery is the only artery in your entire body that carries deoxygenated blue blood. Remember that. And whoosh, we're out of the heart and on our way to the most critical pit stop of the entire circuit. This is the place where everything is about to change for us. So the pulmonary artery carries us to the lungs, where it splits into these tiny capillaries that wrap around the air sacs. And in here, something amazing happens. It's a simple little trade-off. We ditch our waste product, carbon dioxide, and grab a shiny new molecule of oxygen. Just like that, our blood is bright red, re-energized, and ready to go.
All right, we're refreshed, we're oxygenated, and we are heading back to the heart for the main event. We're talking about the left side now, the powerhouse of the whole operation.
So our ride back to the heart is through the pulmonary veins. And here's the flip side of that exam question from earlier. These pulmonary veins, they're the only veins in the body carrying that bright red oxygen-rich blood. There are 4 of them coming back to the heart. All 4 of these veins empty out into the second waiting room, the left atrium. From there, the oxygenated blood passes through another crucial one-way door, the mitral valve. You might also see it called the bicuspid valve because it only has 2 flaps. And now we enter the beast, the left ventricle. I mean, look at the wall on that thing. It is seriously muscular, like 3 times thicker than the right side. And why? Well, because it has a much bigger job to do. It has to generate enough force to push us to every single part of the body.
Then, kaboom! The left ventricle gives this massive, powerful squeeze, blasting us through the final door, the aortic valve, and into the aorta, the biggest artery in the body. From here, we're off to the races, branching out to deliver oxygen everywhere, from your brain to your pinky toe. And that, right there, completes the circuit.
So just to recap the valves, because they can be tricky, it's really just a simple open and shut timing thing. When the atria, the waiting rooms, squeeze, the tricuspid and mitral valves open up. Then, when the ventricles, the pumps, squeeze, those first two valves slam shut, and the pulmonary and aortic valves are forced open. It's a perfect coordinated dance to make sure blood only ever moves forward.
Okay, so you've got the path down, you could probably draw it in your sleep now. But why does it matter so much? Well, let's talk about what happens when this perfect system breaks. This is what connects the anatomy to the real world.
I mean, why is this so critical, not just for your test, but for your future career? Because a tiny blockage, a faulty valve, any little problem in this pathway can bring the whole show to a grinding halt. Think about it. The heart muscle itself needs oxygenated blood, and if its own supply gets cut off, the pump itself starts to fail. When one of those little arteries feeding the heart gets blocked, you get something called myocardial ischemia. The heart cells aren't dead yet, but they're suffocating. They're starved for oxygen and they can't contract properly. This is literally the beginning of a heart attack.
And this is the number I want you to burn into your brain. 20 minutes. That's it. That's the window those heart cells have. After about 20 minutes of ischemia, the damage starts to become irreversible. The cells die, and that's a myocardial infarction. Time is muscle.
So how do we know for sure the damage has been done? We look for this little guy in the blood, cardiac troponin I. When those heart cells die and burst open, they spill their contents into the bloodstream, and that includes troponin. So if you see elevated troponin in a blood test, it is the smoking gun for a heart attack. And I can almost guarantee you, you will see this on your exam.
So look, we have absolutely nailed the plumbing of the heart. But what about the wiring? What tells the heart to beat faster when you're running for the bus, or slower when you're sleeping? That, my friends, is a whole other level. The nervous system, the endocrine system. That's your next chapter. And that's how you really start to see the big picture.